I need to determine which of the following series can be used with the limit comparison test to determine whether this series converges or diverges. The thing you want to zero in on is, if I'm using the limit comparison test, then I am dealing with a limit as n approaches infinity. If n is approaching infinity, when I look at the denominator here, anytime I am adding or subtracting things together, and I am looking at n approaching infinity, it matters who grows infinitely faster to infinity. So I've got a Desmos ready to make sure that you are clear that 5 to the n, which is an exponential function, will grow infinitely faster than x squared, which is a polynomial function. And I've got my Desmos ready with x. Now, at first, it may look like, well, actually, you can see that the exponential function, which is in red, is growing faster than the blue x squared. Let me show you what I mean by infinitely faster. I am going to force the y to show a really big scale. Let's see if that's enough. Yeah, that's enough. You just witnessed x squared, the parabola, getting flattened in comparison to an exponential function. What does it mean to grow infinitely faster than another? This is what that means. So, with that said, that means that the addition, or in this case subtraction, of n squared to the function 5 to the n is pretty much meaningless. 5 to the n is so large in comparison that it feels a little pinch on its little toe of some n squareds taking away a small patch of skin, maybe. Anyway, I want to compare to 4 to the n over 5 to the n, which is 4/5 to the n. And when I do a limit as n approaches infinity of the series I was given with this series, I'm creating something that has a 1-to-1 ratio, because this little tidbit is barely taking anything off of 5 to the n, and it's near nothing as I approach infinity, causing them to be in a 1-to-1 ratio.